And we should be going live. And awesome. All right. Hello, everyone. Thanks for joining the discussion about storage costs. We'll start kind of digging in. I will first start just kind of to cover some context and some details of proposals which were posted on the forum, and then we can kind of discuss pros and cons for each one, and if there are any other ideas that we haven't had surfaced yet. Does this sound right for everyone? Okay. All right, so just to give some context, right? Well, why we're here is the costs have been, rising and became pretty high for some of the like specific use cases, like people using multi-sig contracts, which deploys a contract on each account, or some folks are planning to launch products where you kind of need to create contracts for each like group of people, for example, right? So we have like Sputnik DAO with each guild and each team or each squad even having their own kind of contract, or Mintbase where each store has its own contract, and so the current costs are prohibitively high for that type of pattern. Also, generally, like account creation kind of becoming somewhat expensive, and especially if people want to fund it. If some developers want to fund this in an easy way, or we want to have some kind of faucet. Kind of somewhat independent of this, but contract development has been somewhat cumbersome around storage staking, where you need to handle manually like how much money is coming in, how much money coming in for storage versus how much money is coming in for like actual payment and things like that. And then in case of cross contract calls, paying for storage is even harder, where you kind of need to like keep track sometimes, or like send piece of the storage. Sometimes you don't even know how much you're gonna spend on storage later, so you need to keep some amount and send some amount. So they're just all kind of cumbersome. High level, there's actually, at least like as far as I know, there's 3 ways to pay for storage in general. So there's what I call storage staking, and that's what we use right now. This is when you lock some amount of money, base token or other token, on the account, and a inflation of that amount, or in some way pays for the 2 validators or to whoever maintains the storage, right? So just to kind of the basic math here, right? If you have 100 NEAR staying for a year on this account, this is 100 NEAR that's not being delegated or lent, but like specifically because they're not getting delegated, the rewards that would before go to this 100 NEAR are distributed among validators. And so it's a like somewhat indirect way, but to kind of remove these coins from circulation and from staking to accrue more value to the validators or to whoever's staking. So the second approach is storage rent. So this is where if you store some amount of bytes on an account, your balance is like decreasing block by block by some amount of money. And this is actually, we have implemented before, and it was a nightmare for a few reasons. Main one is because your balance is constantly decreasing, which is super weird to people. Also tooling needs to kind of know about what's going on, because like the balance that's on chain and balance that's kind of like virtually computed is different. And then the third option is just pay one time and store forever. And this is kind of where really all the existing blockchains are, like excluding few. And like it has a very suboptimal obviously problems that when you pay once, it only covers costs right now, and it doesn't cover costs in kind of perpetuity, right? but the data needs to be stored in perpetuity. And specifically, for example, Ethereum has this model in like somewhat of like a form, and the growth of state has been pretty exponential actually. This is not the super latest data, but like the growth is pretty exponential. It actually like I think people analyzed and it's pretty pretty well aligned with kind of usage of the network, and so people don't really release data. People don't really kind of delete stuff. So we have been running storage staking right for a few months, and I mean I'm collecting hard data on this, but I don't think we have had that much deletion happening either, right? So even though the storage is pretty expensive, we locking near, right? The idea is that it will get released back if you delete the storage, right? But that doesn't really happen because like most of the stuff is not designed around that. We have a lot of confusion around UI where there's like two balances, like there's kind of this minimum balance that you cannot use, which means there's like another balance, which is what you can use. There's a total balance. And we also have all the lockup stuff on top of it in staking. So you actually have like a lot of concepts just to explain like how much money you have, right? And that's been very confusing. And costs are high, right? So this has been kind of a problem for various reasons. So I want to mention kind of one of the approaches here, which is like to approach that problem like pay once, store forever, is actually to not store data on validators, right? And like generally the cost, right? The cost of transaction, because it's a one-time thing, it doesn't include the storage costs that kind of goes through in perpetuity. And one way to solve this is to actually not require validators to store it in perpetuity in the first place. And this is actually kind of similar to saying, well, the validators will not store much, right, or very little, but we get to push everything into kind of indexers and like nodes that will index data outside of consensus. There's still a lot of problems. I mean, the folks in Ethereum have been working hard on kind of figuring out how to make this work. I think the current approach generally is like you need to have like full nodes or like application specific nodes, which will produce blocks pretty much and then give them to validators. So we kind of have a lot more like minor extracted value things, which is like kind of by design, and a few other things. And at least like from my perspective, one of the bigger issues is like it adds latency, because now you kind of need to like, as you're sending a transaction, it needs then to get all the data around this. Ideally, it should be formed in a block right away, because otherwise, like if you have two transactions to the same contract, right, and like they may not merge because like the state is different and stuff like this, so it needs to be formed in a block, and that block goes to validator, and it goes back, and the next transaction can only arrive, right? So we're not going to discuss this because it's like a major change, and still a lot of research needs to be done. But I just want to mention this.
Yeah, actually, a plug here. We're going to do a whiteboard session with Doncrowd Feast this Thursday on stateless validation, and see what Ethereum's plan is for it.
Yeah, that would be awesome to hear. But we're not gonna, at least like in short term, I don't think we're gonna consider that. But it's definitely super interesting as it solves some of this kind of more conceptual problems. Cool. Is there any more context we should discuss actually before going to the proposals?
Well, you can also mention pros of having state staking, which blockchain state is kind of reliable now and cannot be exploded. So you mentioned the problems, but at the same time, like if we say storage is free, then we'll have problems. So we should say why we even did this.
Yeah. So I think the two benefits of storage staking, right? Why we did it in the first place, and why like it is on what I call on paper a really good idea is twofold, right? One is it's a little bit better aligns the kind of usage patterns of the blockchain with like base tokens value accrual. So pretty much as people use, for example, ERC20s or other things, right, the storage usage expands because you create new addresses and stuff like this. And given you're using these resources, like for example, on Ethereum right now, it's not really proportionally kind of how the storage expands to value accrual, like to how much Ethereum is being spent on doing this. And so storage staking actually like, proportionally logs that amount of like base token towards a kind of amount of usage. And kind of the flip side of this is also kind of controls how much storage you can spend. And because it is charged in base token, right, it has like a very explicit, like as the storage amount increases, the supply, like available supply decreases. So there's also kind of a mechanism around to control that people will not store too much. So this is where the kind of the conflicts comes in, or like because like from perspective of developer, you want to store more. From perspective of the system, you want to kind of have a somewhat fixed amount of storage in the system. So yeah, so there's, oh, anything else actually?
I think there is some other which has a different system where there is a fixed total amount of storage, and there is a storage auction where there is a market where people can buy and sell the storage, so the market sets the price for storage.
Yeah. So there is pretty much a way to kind of price storage more dynamically. I think when we explored this and when looking at some of the implementations of this, the main problem was that like people like to speculate on things, and so there was a lot of kind of unnatural things happening on those markets, even though like presumably markets should be somewhat they should be optimal, but they're not, right? So people were buying out storage for no reason, and then driving up the prices and like selling them at high price, kind of just to make the resource more scarce.
Well, I'm not saying that this system works well. I'm just saying that there is one more approach that is actually exists.
Yeah, no, you're right. Yeah, I mean, I think generally there's like a little bit more, mechanism design approaches, which are more, as Evgeny said, like around kind of creating auctions for storage with various models, and I think EOS has been doing that model as one example. But yeah, so far hasn't been shown to work very well. So here's like a few specific proposals that I would like to discuss, but we can also discuss something in between or some other options. So the simplest one is just decrease the cost by 10x. And so kind of the reasoning there is like the calculations I was doing was like based on specific parameters, and there's definitely like a 10x there to reduce, as I was like rounding up a lot and like using a kind of a $1 near price as a benchmark. And so this would reduce things like by 10x. So like our accounts are 100, like basic account is 100 bytes. So this is without keys. So that would go to 1/1000th of a near, and then kind of a somewhat standard 300 kilobyte contracts would be 3 near. So that definitely would help.
Add to perspective what it is like for 2 other metrics. So we can compare this to average transaction, like average function call for gas, and also the maximum state you can acquire if you like lock entire near supply into the storage. So currently we have, I think, 10 terabyte for the total state that you can acquire if like full near is locked for storage. And it was already slightly higher than where we wanted it to be, but kind of unrealistic to reach. And this proposal essentially bumps it to 100 terabyte, which is not completely insane, but kind of on the border of like getting hard to exist if someone actually acquires so much storage, which is probably not realistic as well. And the second metric is the cost of a transaction. So the cost of a transaction, it's better to measure in teragas. So something basic is around 7.5 teragas, and 7.5 teragas is, I think it's around 0.0001 or 7 years. So it's like 1/10,000 of a cent. So it's like 10 times cheaper, or like 100 times cheaper than 100 bytes, right? Something like this. So our cost to write this data is probably around, from gas perspective, is 100 times cheaper than to persistently store it, or like to keep it in locked state, if I'm not mistaken.
Yeah, I was kind of didn't get to that math, but yeah, yeah. Well, one thing I do want to mention that like evaluating full supply map to storage is definitely not realistic because of the like even if we imagine that half of the supply locked in, then the price of near, like just because of supply demand, right, will be like outweighing a lot, right? And I'm not even saying that, you know, we already have like actually the supply that's outside of staked and locked funds is pretty much almost non-existent in the first place at this point, right? So but yeah, I mean, it's definitely worth noting that, yeah, even with this lowering, it's still pretty the storing, like you need to lock, yeah, about at least 100 times more in near than the fee to actually like process it. So this goes into option number 2. We lower by 100x. And I mean, the justification here is mostly around like, so this calculations don't really account for, you know, price decrease in storage, and like the calculations in general were like pretty basic. They don't also account for like contraction in the supply as well, and kind of the like supply demand there. So this is really trying, like, I wouldn't say that the math at least like fully worked out and I have like a full model here, but like kind of accounting for storage decrease, right? For example, using models that we've used for like future storage price, and also do like kind of evaluating contraction on the circulating supply as well.
So I think what is roughly the curve they're using for this?
I
mean, are they expecting it to become exponentially more expensive, or like what?
Cheaper? Yeah.
Oh,
I think, yeah, I have a paper somewhere, but yeah, I think it's roughly like it becomes cheaper like every 2 years or something. So yeah, some kind of exponential decrease in price to store 1 byte, like for hard drive per se. I was actually trying to pull the data from like a cloud provider, but like I only found EC2 costs, not the storage costs. But anyway, I mean, we can like we can pull the math more accurately later. I think like the negative side of this actually becomes, you know, a little bit too cheap on the side of like really flooding the data, right? So now if you want to store something like 100 gigabytes, right? This becomes now like only 100,000 near, right? So this, and 100 gigabytes is kind of current state of Ethereum. And so this is definitely cheap, and from the perspective of costs that like people would incur, and definitely requires that we like start sharding things reasonably quickly to be able to kind of capture it. And I think this is where one of the kind of questions that we've been discussing a lot but haven't really finalized is like how to balance sharding on transaction throughput versus sharding of storage. So if there's a lot of kind of storage sitting there which is not super active, but like it still makes sense to have shards which are reasonably evenly split on amount of storage. I know, Eugene, you were pretty against the 100x decrease on from perspective of the cost as well. I mean, like spamming as well.
Yeah, I think it's still like, I will probably comment after all three proposals on like my perspective, but yeah, I think it's just getting too dangerous to go like straight 100x.
All right. Well, so I mean, these three proposals are actually kind of in a like, doesn't mean one doesn't actually exclude another. So the third one is layer on top of 100x to actually burn the fee and then like merge the charging into gas charge. Also, this burn and charge can also be like separated. So the reason for burning is actually, first of all, if we burn, we can actually, and for example, not return it later. This easily justifies reducing the cost by like 20x. Now it removes a lot of kind of mentalities that people want to free up the space, like the benefit of freeing up the space. Some of it can be like worked back, like what Ethereum has, for example. It gives like a gas chargeback. So like if you remove data, you get back some gas while you're kind of running. And merging to gas is really about improving user experience, right? Like the contract development is way too complicated, and users and developers like paying two separate fees, attaching balance plus gas fees, kind of complicated. So like we can just increase the storage right operation cost, and so that actually increases that. Like I looked at the storage cost and like kind of increases that gas usage by like 100x. That specific operation to do that. I think the kind of the important piece here is indeed on one side costs are low, but it's still actually like if you compare to our gas usage, it's actually pretty high. So it will bump your gas usage, especially when you're deploying like large contracts or like upgrading large contracts. But it definitely improves kind of experience and is more familiar for developers, for existing blockchain developers. And like one option around how to burn is actually like it can still be charged in near per byte, so like not in gas actually. So like to not be affected by gas price, and your chargeback also can be in near per byte. So you just get like we actually record what's the gas price for this transaction. You just get back that amount of gas proportional to how much gas, like how much gas price you paid for this gas. And actually refunds right now would convert it back to near. So this all kind of like there's a few of these formulas in the proposal on the forum. I mean, that's pretty much it for the kind of the proposals I had, but curious to hear what other folks are thinking about this.
So Also proposal 0, like how it actually addressed without this change. Basically, so for the fungible token, the way we design it is we created explicit account registration API. So basically, any action you do on fungible token do not require you to pay for the storage, except for initial registration. And the way it works is like you have a standard that's saying how much tokens you need to attach for this particular contract. If you want to start interacting with this, so you first attach this amount by calling it. That pre-allocates essentially your account storage, assuming it's fixed. So it would not work with like old contracts, which has dynamic storage per user. And then once you're done using it or you don't want to use it, you can claim the storage back by essentially closing your account on this contract. So this is kind of workaround with the storage fees that we have for lockup. The main reason here is if the account is one to many, which means multiple users use this account or contract, which is majority of contracts supposed to be like this, then to prevent kind of draining storage and Sybil attack, you require payment. And this payment can originate either from you or from someone else who want to send you assets. So it creates some problems still, because now you need to think about whether you register it or not. But this is usually done on the UI side. An example is like Uniswap. You go to Uniswap, it checks that you register on a token that you want to receive. And then if not, it's saying you need to register first. You register by like allocating your account, then you can buy a token by Uniswap. That's a background on like how it works right now.
But this still doesn't, oh, sorry. Yeah, but the problem is that still today deploying contracts very expensive, right? And an example is the 2FA, like people just have 35 like near locked there, and that's very suboptimal. Yeah. Yeah,
so, and for replicated contract, the solution would be you have some kind of reusability of contract binaries where the asset is like the storage that needed to store it and deploy it burned once instead of locked, and then all like validator will be able to keep it in cache, and you will be just reference it by hash. So this piece is far from being done, but that will address the problem of replicated contracts such as 2FA, lockup contracts, maybe NFTs, or anything that is sharing the same instance of the code.
So if we do this, are you suggesting that there is no need to reduce the storage cost?
I'm suggesting that potentially, yes. I still like the idea of dropping it 10x. I don't see immediate abuse if you just go 10x, because it's still expensive to store large amounts, not as expensive as right now, and may create certain problems originally, but still reasonably priced. But I'm saying that like longer term, we hopefully will arrive in a place where contracts are cheaper by optimizing some stuff, maybe not only NoSTD, but rewriting certain libraries. So Rust contracts are cheaper, assembly scripts contracts are already relatively cheap. And given 10x reduction, we'll go to like very low price per unique contract. For non-unique contracts, it's still fine because it's a one-time payment once you finalize your binary, pretty much.
Yeah, I mean, I think the contract is definitely kind of the current big pain, but I think the user storage is also there. It just kind of flies a little bit unnoticed because of the contract storage. Like the problems we've seen, right, with wallet is when people kept adding access keys. So I think generally, like the pattern is that people are not, they're not like, hey Nate, the people are not planning to remove stuff from blockchain, right? It's not a pattern of like, using limited capacity on blockchain. It's more about, keep storing more stuff. I think that's kind of one of the problems where like the storage taking is just like misaligned with how people are using the stuff. I just also wanted to share this is RV's pricing data. So it's not really exponential, but it's kind of, I feel like there's like actually a change in
flattening
progression. Yeah, so like I wouldn't, but Alex also shared the costs for AWS, and so this looks.
It went down to X over the course of 7 years on the slide, from December 2009 to December 2016.
Well, I do want to mention this is S3, which is a little bit different from like I was looking for EBS, which is like active, because I definitely agree that like a long-term storage, like there can be doing a lot of stuff there, but like active storage that validators need to have hot for executing code, that's I feel like where the limiting factor.
I mean, I don't know whether Alex is alluding to this, but Ethereum has this regenesis plan, which is like they kind of just having basically a separation of hot storage from cold storage, and validator only need to keep like storage from some recent number of blocks, and then they kind of relegate the old data to some cold storage that they have some separate provider and they can query from, I think.
Well, so this is going. I mean, this is going into like more stateless stuff, I think, in general. Like, I think like if going stateless, it makes sense to keep the hot stuff like contracts and some like recent data on validators anyway, and then just like leave all the stuff that hasn't been fetched in a year to somebody else. So like you actually need to include in a transaction data if it's like too old.
So I just want to jump in and say from the developer relations perspective, having those high storage costs is really crippling for developers in terms of growth and user adoption. And I think that like, this is not the time to be like limiting the data when we're just in the first small stage. Like maybe if you want to set some kind of like rail guards so that like insane things don't go in there. So like at a certain point, it kind of starts going exponential. I think that's fine. But like, I'm in favor of the like 100x reduction because I think that we should be encouraging people to build. We should be encouraging users to come on. We shouldn't say like, if you want to play with something on Near, by the way, it's $10 to like step into the ring, right? And that was never the original intent, but somehow we landed here. And I think this is a way to address that in the immediate future.
And just to follow up on what Danny said, this is Nima. In the case of Mintbase right now, I think it's like over $75 to deploy. So even 100x reduction is a significant fraction of $1. Like one would expect Near to cost actually lower than that. So even 100x is not like, I think it's not enough, but it's more manageable.
Right, it's because of the model of replicated contracts. So
yeah, I think for Mintbase is probably having global storage would basically just address this problem.
Yeah, so Thor for Mintbase here. As context, we're currently deploying contracts that require 35 Near in a factory pattern. So that translates to roughly $70. I worked a bit today on integrating the no standard pattern, but it looks like that's still in development because it doesn't look like it's completely covering features. So for instance, cross-contract calls are not currently something that you can do with the no standard pattern. So we're looking for all sorts of ways to reduce contract size.
Yeah, so I mean, like generally, why I would suggest going for 100x right now is actually more reasoning that Danny provided. That's like right now we're not really kind of need to be perfect, and we just need to deliver developer experience, and then start like we can improve things like how exactly we're storing stuff, like on the back end over time. Like again, stateless stuff or whatever can be improved over time on the back end as the need of that arises. And I mean that's kind of why I mentioned stateless validation in general, because like I do think it's a solution in some shape or form. Just it's not needed right now because like that's not actually a problem in the first place.
And Bowen, you were talking about that we'll have it all solved when we figure out the the reduplicative code. That would help a lot. But I also read that it kind of doesn't really work with sharding. Is that, I need to read more. But is
well,
that
I mean, it works with sharding. It's just that it's not. I mean, we have not started implementing anything anyway. I think the design is not finalized, I would say. So it might take us some time to get there. It's definitely not the fastest thing. For example, we can do the storage price reduction in a very short period of time, but for this, it would take much longer.
Got it. So no STD is not an option for us, but we will have to wait for you guys to manually reduce the storage cost just as a hard-coded thing, and then this duplicate code might get fixed maybe a year from now. Is that?
Oh, I think it's less than a year, but it would probably be several months. Yeah.
I mean, no STD. I'm assuming. I mean, we'll like just get the features you need as well. So, I mean, if there's like specific thing that doesn't work, it's just like missing implementation of the couple of functions in SDK.
Oh, yeah, I think Thor was saying we just implemented the no STD on a side project just to see if it would reduce, and it reduced us by like one near token.
Oh no, we can't even compile that. That's correct. That's incorrect, because we wouldn't be able to implement it because the store contract currently uses cross-contract features, which are not currently implemented in the near SDK pure library. So I don't have an estimate about how much it would reduce the store. That is safe to say, but it could reduce it by a lot, by a little. It's just that the no standard library is not complete, it would appear.
I mean, from my I mean, it's a separate, but like
side, like if you reduce storage 100x, we cannot bump it back. Like it will break contracts that are already there. So that's why I don't advocate for trying to go 100x, because if people start abusing it as for doing this, then it will be very unfortunate state where potentially we cannot really address it with any like reasonable actions, such as like the only solution is like delete these contracts, bump the storage, break ton of contracts, do a hard fork. So you don't want to go there.
Yeah, I agree with that. So can we actually talk more about the last proposal of burning just burning tokens for storage? Might be interesting idea.
Well, I mean, I think it still includes a kind of 100x reduction. So, like from perspective of like if we're thinking of an attack surface, right? The attack is the same. It's just like instead of locking that money, you're kind of burning that money. So that's the difference.
Well, I think that's a pretty big difference if you're talking about that much money. Like whether you just lose it or it's just temporarily locked.
No. So like even if temporary lock, it's not a problem. Like you can create a state. You can grow like archival state right now much cheaper. So it's a persistent state. So
I see.
you basically lock in it until the network goes down, or like whatever it is. So it will not address, like you may not be able to recover the funds. So from this perspective, does not change the vector of attack.
So can we address the challenge that Eugene brought up about the abuse of storage? Because I think the legitimate use of storage for projects versus the potential for abuse are two different subjects. So is there a way for us to set up a threshold or some guardrails to protect the network from that kind of abuse, maybe with an exponential rise in the cost after a certain stage, while still giving enough space for developers and users to benefit from a significant rate reduction? So like a tiered approach?
The general answer is no, because if someone wants to abuse, they will be abusing the cheap storage, and the expensive storage will be left to the good people.
Also, like prioritizing work on like replicated storage, I think will bring huge benefits and differentiator for Near. It essentially creates not stateless, but it allows us to have like incredible stuff that we haven't tried using before. Short-term going 10x does not fully solve the problem of like having this type of replicated contract that Meanbase is trying to focus on. But it certainly helps to bring it down. Not exactly to the point where it's as cheap as no duplicated contracts.
So I guess like the thing that, so I think like everybody agrees that we want to lower at least by 10x. So let's set that bar at least on this call. We'll see. I mean, if anybody watching, let us know. But I guess like yeah, the kind of main question is like, if we lower more than 10x, like there's a bunch of stuff that's coming to reduce kind of for these patterns. Like yeah, multi-sig contracts will also get reduced. So from my experience, NoSTD brings like at least like from just like pretty basic contracts, it like cuts out like 200-ish kilobytes. And then and if we also remove Serde, so maybe even more. So it's probably like reasonably assume it like a 5x reduction from the current contract size with NoSTD.
On a very minimally sized repo, I did the NoSTD setup that is linked, and it reduced my contract size from 43 kilobytes to 37 kilobytes. That was a very small, just kind of dummy repo with like one function in it. So I assume that scales quite a bit when you add more functionality into it. But for just the dummy setup, it only reduced mine by roughly 6 kilobytes off of an already very small contract.
So the main, like the one that's impure, it still uses Serde, and Serde is pretty heavy. So I like pretty much unhooked Serde. I actually did not use that NoSTD thing. I just like went with raw RPC, like raw SDK calls, and without any JSON parser, and it can lower. And so like we just need a very minimal JSON parser that works. But anyway, we can follow up on this like and investigate that separately.
Right.
But I think the question still stands. Yeah, if like somebody that does want to, you know, like upload the whole, I don't know, like 1 terabyte of data into Near. So one question that I have is like, actually, how much gas will that take to store that in the first place, right? Because like if it's actually like uses up a lot of gas anyway. I'm not sure this is actually like really the problem for an attack. Like right now, for each byte, we are charging. Let me find the parameters. But like, do you agree with this logic in general? That
Yeah, I
this
think
is
our
not really a
gas
problem
is like 1,000 or 10,000 times cheaper to store for the current pricing. So if you do reduction, the gas still not as expensive to store like a gig of data. Terabyte is unlikely. It will probably like take longer.
So yeah, so storing 1 byte, well, 1 byte is kind of hard. Storing a megabyte is, I see, it's only like 300 100s of near per megabyte. Yeah, that's a pretty small amount. Is there any ways we can for now, for example, yeah, I mean what Danny's suggesting, like can we change the price based on kind of how much? I mean, I know this kind of sucks, but like as an intermediate solution, change the size based on how much is taken.
Then you create an auction, right? If you're changing the price back to the higher, then you can allocate storage now.
Yeah, then I can sell it off.
Well, what's the like main problem outside of main mint base? If it's only for mint base, then there's clearly 2 solutions that we should tackle. One is reusable contracts, and we can try to focus on this next. Second is minimize the size of the contract, which we're already doing. Just focus on this a little more.
Well, I do think that kind of current experience is somewhat cumbersome, right? Where you need to send around the near to the calls and like account it into smart contracts as well for storage. Like it's really easy, and I can tell you people don't do this, and then their contracts get in the state where like it actually doesn't like the new transactions don't cover storage, so somebody needs to like donate near into it to cover storage, right? Like that is pretty, like because it's not enforced was kind of the model, right? It's like it's on the contract developer right now to handle it. That's why I kind of suggesting the third option of like burning, like integrating into gas and burning it, but like the cost needs to be way lower for that to actually work. I mean, you were doing that math at some point, right? Otherwise, like the gas costs are not mapping very well.
I would say this is not just mint-based. I would say mint-based are the ones that are being probably most impacted by this right now. But for example, for atomic swaps, we're trying to write something where a new user is onboarded when they can't find existing near keys, and to enable them to do atomic swaps. I think it was like something like minimum 5 near based on the contract size, which means that in order to enable anyone to come acquire near, we have to figure out how to get every single user like almost $15 USD to like just let them come step in, or even just like the cost of acquisition of like a user if we want to bring them through a traditional method of like a full near name into the ecosystem versus restricted key access is really, really high. So we're essentially like cutting off our legs before we have started running.
No, it's probably
and then
correct implementation. At the same time, like our like accounts are not limited. 2FA is an issue, but again, it's addressed through reusable contracts. Account and like restricted access key is in 1 year, you can deploy 50 of them.
But a restricted
50
access
accounts per year.
means that we don't get to acquire the user and bring them into the entire ecosystem. It means we restrict them to that one application, which again is fine for a use case, but it's not in our collective best interest as a protocol that would like not to be an empty playground.
So there's 2 ways to address this. One of them is what Evgeny Kaplan suggested, which is on cryptography side of the key. It is like 2FA that only restricts for certain actions. Second is what Matt Locker is doing with his onboarding, where a restricted key is converted to a full access key, or like full account, by using implicit account models. So both of them do not require any contract to be deployed, and the storage is like limited to the size of the keys plus the base of the account.
Yeah, but I think that kind of the reasoning is that like we want more like people using named accounts, right? Because they are better for user experience, you know, they're better for like social things as well. And like we can use implicit accounts, and we should, but like anywhere where we can convert people into like named account, like that would benefit, right? And right now, like it is kind of like it is expensive, and it's also like it's complicated. Like that's like from my perspective, actually complicated is a little like I think reducing by 10, you know, it saves us some expense. But the complicated part. But the other part we haven't discussed is, you know, if in case near, you know, price actually changes, like all of this kind of converted to stable currency is also would increase in price, right? So, I mean, that's a thing we kind of try not to think of just because it's like not really able to analyze here, but like it is something we should be kind of considering as well.
Yeah, and in Ethereum,
we can also do faucet.
Gas price changes dynamically, right? As the token itself does, to prevent that crazy spike from happening. So
well, if Ethereum is a bad example because of like they actually not like so I mean that again the problem is people don't want to release storage. Like that's a real problem, and like I actually think if we acknowledge that, right, then like this is where we need to figure out like what's the next steps. Like I mean not for right now, but like how we're gonna be dealing with massive amounts of storage that's gonna be like accumulating. So yeah, so I mean
useful storage, then current model is kind of like doesn't address it. If it's useless storage, then the current model is kind of addresses it.
By useless, you mean spam, or what do you mean useless?
No, it's just like storage that's not needed on chain and stuff like this. It kind of discourages you to create the storage, but at the same time allows you to claim it back if you somehow recycle the same amount of space by replacing the existing storage, which is like all fungible token do, and like some other contracts can be designed similarly.
But do you want to? I mean, this is like just adding more and more requirements on kind of contract developers. That's what I'm saying. It's like it's just more and more cumbersome to develop, which is kind of what we're not supposed to do.
No, it's a trade-off between the price, like the price of this action towards the hardware. So like on our side, the compute and like writing into state is fairly cheap, coming from like actual estimation of how much it's costs. So the only limit is validators nodes. If you go like too crazy on the decreasing side, then it means we'll need to do optimization of the storage very fast, focus on state sinks and like stuff that actually, like, if you have a terabyte of data on one shard, then you need to be able to access it very fast. At the same time, you need to make sure you can replicate it very fast for the new node, and like when you onboard in a node. So you need to optimize network, sync, and access. Right now, it's kind of slightly less of a problem, but if you go this path, it will be like immediate problem that we'll need to start working on.
What do you mean by this pass?
Well, like if you reduce, let's say 100x, then like we'll need to start focusing on terabyte of state very soon.
Well,
Right.
How soon are we talking? Because like terabyte of state is a shit ton.
Well, you don't know, right? Because
year?
people can just take advantage of.
I mean, even with the current price, this would take like a million near to do, right? That's a lot by any definition.
100x or
That's a
the
million of
current
stake,
price.
right? Million of stake near. So if someone just wants to do it for kicks, they can.
Well, that's why, like, the second thing is, yeah, with 100x, I would suggest us to switch to burning it, because like for that would be one of the reasons for sure, and also like just making everything simpler. But I think that Eugene's point was that staking and burning doesn't make a difference if you kind of doing it for attack purposes, because like you're betting on a failure, not on that you just do it and then get it back. So like if we assume terabyte of like actual useful storage because people are launching all kinds of stuff on near, then I mean that's kind of
but they can attack using a smaller amount on archival nodes, as Eugene suggested. They just, for example, I just like use 300,000 near, and then I just use that, and I deploy that amount of data, and then I delete them. But then the archival nodes, they just get fucked.
Yeah, but that's the current state of that. That's currently like you can just store a lot of data in the transactional data. You can literally send like blobs of data in transactions. Like each transaction is a megabyte. Send 1,000 transactions per block. Each one is a megabyte.
Sure.
That's like a gigabyte. Well, I don't know if that's not going to fit.
It can be addressed on like preventing query of archival nodes on like historic state for like execution. This way, you only need to care about the state sync of archival nodes, so like giving blocks away. So if you want to run this, you either have to query indexer, which is designed for like tracking some part of the state, or like it can be addressed like transactional state is different from executing something on historical node on demand. And that's why you don't need to like keep it in state. And that's why this current model makes sense, because you only keep the current state in state, or like maybe last n blocks in state until it's finalized, and then you delete it from your quick access and only keep it like as a view where you can shift from a past, similar how TurboGas optimizes this.
Yeah, I think we're over time. Maybe you can.
Yeah. Well, so like I do want to like what like I mean, given I think Eugene, well, and Bowen potentially like are against 100x reduction. Like what would be a reasonable, like what do we need to commit to make 100x happen now for next whatever 6 to 12 months on a kind of on the back end improving to make this happen?
I think solving contract size is one. Going 10x lower right now, or like on the next upgrade, is also going to help. And the third is making replicated contracts a priority, which is like we discussed this, and it's not as terrible like implementation wise. So
no, I'm asking
so
if we do 100x, like you're saying, we'll need to deal with like 1 terabyte, of storage syncing, stuff like this. That's kind of more like what do we need to do to get 100x to commit to doing 100x now?
Well, I just don't see how like going now when some stuff is still unstable gonna help us in the short term. Like outside of the developer, I think we'll have more problems on validator side potentially. If someone like just deploys 4 megabyte contract because it's cheap now.
Well, it's still expensive to run.
One problem.
Like the
Maybe.
megabyte contracts are becoming more expensive to run, right? So.
Not really.
Well, we actually have pretty like currently we have somewhat linear dependency on the contract size and
yeah, but that moves to deploy. So you only pay once for size. So that needs to be
one thing I was going to suggest with the replicating contract as a priority. So every mint you do, every NFT you create, you have to add storage, right? What we can do if we want to like fill stadium seats, if we do ticketing for a stadium, to deploy the contract, if it's really tiny, that's really nice. But if we wanted to do it for a stadium, we could do a thing called lazy minting, where basically the customers mint, and so they would pay the storage per piece. So we don't want the stadium to have to pay hundreds of millions of dollars for the storage of minting all of 300,000 tickets, right? But lazy minting would kind of solve that piece. But the store deployment being ridiculously cheap would really help. So if that helps with the.
But you just moved. I mean, the cost is still the same, right? You just moved it to pay its users. I think, like, at least like from perspective of cost, we want to reduce costs for everyone, right? I mean, it's the same as like if like what matters, like for Eugene, what matters doing, right, with a demo to get access keys and just accounts work, right? That access key paying for that is still like it's non-zero, right? And
I understand. The point is just saying, here's a way my brain is thinking about what customers we're going to be going after. And so you guys can take that information and go, well, this is one of their ways of actually using this technology. How would that help with storage processing? So it's suggestion.
No, yeah, I appreciate it. Yeah, you're right. Okay. Well, I mean, I think like we should go with 10x either way. It sounds like everybody's on board. I mean, specifically for min base and like multi-sig and those things, we should like definitely get the NoSTD SDK going. I would really like to see like can we bump it, to 100x reduction? Like what would we need to handle? Like can we commit to like going just like partially stateless, for example, in a year or something like this to do that? Because like I mean, as Danny pointed out, I think like right now is the time to definitely grow the usage versus like trying to be super careful versus like
this 100 you can do Twitter on chain, and like you'll face problems of like people doing crazy stuff on chain that shouldn't be on chain. So because of how cheap the compute, we also like have to bump the compute or like access of the storage on the gas price, and that will affect other contracts because they rely on cheap writes. Like our fungible token transaction will get more expensive if you bump the price of writing. So right now, overwriting is super cheap, and this is why lots of transactions are possible. But if you go that every operation increases storage, persistent storage, then we'll have different issues.
Danny is also asking if we can do something in the middle, like 20x.
Well, it doesn't affect as much. Like we're currently trading stuff that should be addressed differently.
Danny, do you want to like? Do you have a specific reason for 20x?
Yeah, I think just in terms of a short-term patch, at least that brings down the acquisition numbers of new users and some of the smart contracts down to like previous more reasonable levels. And so it gives us a bit more of a patch. So like that would bring like minting a contract down to like $3.50, getting a new user, you know, down to like under $1, you know, it just, it makes the overall acquisition cost for new applications more reasonable. Again, I understand the challenges with having to think about edge cases and attack vectors and the attack surface that we're opening. So like, I respect that you're trying to keep that in mind. I just want to be an advocate for our developers and our users so that we don't end up keeping everyone out just by trying to be very vigilant about the bad actors, that we also block the good actors from participating. So I think that if we did this 20x reduction, it would be a short-term patch for us to think about all the other challenges and all the other ways in which we can address this in a way that's reasonable and thoughtful and like protects the network long-term, but also enables us to move forward and to keep things manageable for the developers, the applications, and the users who are playing in the near space right now and who are building and who need a right now solution.
Yeah, I'm pretty sure that like we should address every problem with a proper solution instead of just like saying, let's go cheaper. Like it's similar argument to gas, where the price of gas can be dropped to zero because we have inflation and it brings a tax.
Well,
So-
I mean, the gas is still like not like somewhat of an auction, right? So like as there's more usage, it will like the gas price will increase. So like it's just we have enough capacity, and you know sharding is like allows to increase capacity on like you know day level to affect this. Okay, well let's wrap this up. We're definitely over time. I mean, I'm if we can justify 20x, let's do that. I think that's pretty kind of, it still was within reasonable of like calculations that were originally done on this. I mean, yes, we should definitely do the kind of longer term stuff. That's not a question. I think like it's worth thinking again. Like my main problem is the current like usage is cumbersome, and the way people use it is more to store kind of forever than as a you know store and remove kind of thing. So, but yeah, let's go with just kind of this fixed reduction for now, and then post a more longer term roadmap on this going forward. People are asking actually how long would it take to introduce this?
A change to 10x or like 20x.
Yeah.
It
That
basically will go to the next upgrade that we'll do.
If it's really urgent, which I don't think so, we can push it like you know almost immediately. But I don't think it's like I don't think that this is threatening the house of the entire network at this point. So yeah, I suggest we wait until the next release.
So to explain the urgency a little bit, our big pitch to all of our customers on Ethereum was it's too expensive. It costs over $80 to deploy a store. When we go on testnet or even mainnet and we deploy and it's the same price, they're kind of look at us and go, why'd you do all that? so it's going to be a PR nightmare for us, really big one. So there's urgency.
I mean, does that urgency dictate that we should deploy it tomorrow, for example? Or like what is the timeline you're looking at? Is it like looking a week, or like a day or like 2 weeks, or what is?
So we're trying to release on testnet on for ETH Denver when we do our thing on Saturday, if everything goes to plan. That's testnet. So that gives us a month of basically a couple weeks of testing the heck out of it. Then the audits will start 2 weeks after that, and then mainnet month and a half from now. But there's definitely going to be the PR piece of, wow, it actually deploys this. It costs 40 near to deploy on testnet. Is that going to be the same on mainnet? And we'll have to say, yes. Why did you guys move everything to near? And we'll have to say, well, there's a plan to make it cheaper. That's the
okay. So basically, I'm hearing that we should deploy this within a month. Is that correct?
ETH Denver is in 4 days. That's when he's going to do PR.
Oh, I see. Well then, okay, I'll have a discussion with Eugene later today to see.
But if I hear it right, we need to deploy on testnet within a day, and then on the mainnet within a month, right? Give or take.
Yeah, mainnet's probably a month and a half. As long as we can.
Yeah. Okay. Well, we can definitely deploy this on testnet within 4 days.
Thank God! Yes, that'd be great, because then we can see it in action, and it won't be a we think it might happen. That would be a huge help for us.
Yeah, we can definitely, we can, I guarantee you we can deploy this within 4 days on testnet.
Yeah, you know how things always take longer than they should. So a month and a half, to, as it goes.
Okay, sounds
cool.
Good.
Yeah, I mean the mainnet is like atomic swaps and multisigs. That's who's waiting on it on mainnet kind of. I mean, I don't know about atomic swaps, but multisigs are waiting on this right now. So
yeah, we have atomic swaps coming in about 4 to 5 weeks. So it would be helpful to have that.
Yeah, I think a month is like quite reasonable. We were going to have another release anyway, so yeah.
Okay.
Thank you.
Sounds good. All right, thanks everyone. Thanks Nate and Thor for joining and providing feedback.
Yeah, thanks for having this. Very clear.
Thank you for having this meeting.
All right, awesome.